So, let me show you some examples of how this is done, and then I will also show you what this is really constructing as a model, because we need to really peek into what is there inside, so that it becomes a lot more clearer to us than what we just read in the theory side. Okay. So, for that I am going to be showing some code first. I am going to be explaining that, and then I will show you a debugging session of that, and then I will show you how a particular word when we take in the bigram, and what are the combinations of the second word that is coming after certain word, and what are the probabilities associated with that, and then how the model looks like, and so on and so forth. Okay. So, now let us look at building a bigram model code. As I mentioned in the previous session, the code is available in the GitHub. So, only thing what I have done is I have removed the corpus location. It is giving, I am going to give you an exercise here. Instead of you running this code, you have to really take a corpus and then combine this code and then see for yourself. Okay. Only one thing I just want to mention you here is, do not take a very big corpus. Okay. If you are running it on your small laptop or a computer, big corpus would take a lot of time, sometimes more than an hour to build the model. So, take a corpus which is about 500 to 600 sentences, and then run the application. So, in the actual code, I have actually commented the portion of the corpus, and you have to really fill that up and then run the code. So, by doing that, you will also get the experience of really running this. Okay. Okay. So, now I am going to be building the bigram model. Okay. So, in the bigram model, what I am doing is, first I am creating the dictionary. The dictionary is for every combination of what is the probability or the frequency of each of those words. So, that I need that kind of dictionary. So, I am creating the model as a dictionary. Okay. And then I have taken one physics solution example or the problem example, and then I have about 272 plus problems there, and each problem is about 3 lines or 4 lines. And then each problem is considered as a document. So, the entire corpus contains about 272 plus documents. Okay. And then I am considering each one of them as my sentence, each document as a sentence. Okay. So, I am converting them into small letters. Okay. I am tokenizing it, converting into small letters, and then I am only picking up the alpha words. Okay. I am not considering any numerical, alphanumerical and so on. So, I am only considering the words that you find in the dictionary. Okay. And then I am going to be constructing the bigram. So, there is a if you use NLTK, there is a function that converts your sentence into bigrams. So, you will have 2 words for every sentence that you convert into bigrams, and then I am going to be constructing the binary bigram model using those words. For example, if W1 is how and R, okay, so this is converted as how R based on this, okay, and then for the bigram model, this is the word 1, word 2, right. So, when it goes through the entire corpus, it keeps looking for whether this particular combination of words occurred or not in the earlier sentences or documents. If it occurred, it increases the count. So, in this way, the bigram models are constructed as a frequency initially. Okay. And then we need to compute the probability of that, correct. So, we need to distribute the probability mass for all the bigrams starting with W1. Okay. For all the words starting with W1, I am going to be capturing all the bigrams, and then for every combination of the word starting with how and W2, I am going to be finding out how many times W1 has happened and then compute the probability. So, for example, if you look at how, there could be several words that can occur after how, right. So, for all those words that start with how, so we are going to be distributing the probability marks. For example, this particular combination, if I have about 5 words that formed after how, so I will have the probability mass distributed for all those 5 words. Okay. So, when you sum all of those, you will have the value to be equal to 1. So, this is how I construct the bigram model. Okay. And then the first part of the language model exercise is to predict the next word. So, now given the first word, I need to predict the next word. So, how do I do that? So, this is how we are doing it. First is we build the bigram model like what I had shown in the previous slide, and then I am going to be getting the second word based on the first word. So, this model contains the dictionary of all the words starting with the first word, right, and then it contains the second word with respect to the bigram, and it also provides you the probability of each one of those two words occurring together. So, when I pick up the first word and then take the model and then say give me all the second word with respect to the first one, it will give me certain number of words. So, the combinations of the first and the second, you could have had 2 words together only in the entire corpus, or 5 words, or sometimes 50 words or 100 words, and so on and so forth. Okay. So, there could be a combination of so many of them. So, I pick, so this model what it does is it gives me the list of all those words and the starting with the first word. So, instead of picking everything, I want to only take the top 10. Okay. So, I will only pick up the top 10 words for how. Okay. So, all these probabilities of the words would also be known. Okay. So, each one is a word here. Okay. So, when you pick all of those and then find out which one has the highest probability in this. Okay. So, that is where we use the maximum likelihood, right. So, when you pick the highest one, you will say that how is followed by R, so assuming that R has the highest probability in the list of words that we have found for how as the first word. Okay. And let us see how it happened, and then we can plot it, and I am sure you remember those plots, right, like this, and then we pick this particular word. These are the word, right, and then the one which is having the highest probability will be picked as the next word, or predicted as the next word for how. Okay. So, let me show you how it really works. So, in this case, I am using a I don't know which one I am using. I am using Spider here. I am sorry, I am using PyCharm as my IDE. Okay. So, if you use an IDE similar to PyCharm, you will be able to debug the code and then run and then go step by step and see what is happening inside the bigram. Here I have done is since we have already built the model, okay, I am going to be predicting the second word. Okay. As I mentioned earlier, I am going to be giving the first word as how. Okay. For the word how, you see there are various combinations. Okay. How does, how far, how fast, how high, how long, how many, how much, how tall. Okay. So, and then it gives you all the probabilities of those two words occurring together. So, out of which you pick the highest one. Okay. So, let us see what is the highest one. By looking at these numbers are pretty small for many of these. See this, Okay. So, when you look at how does, probably it happened very few times in the entire corpus. The same way, how many occurred a lot less time than how does, and then how much occurred lot more than how does, and so on. There are some other ones which are pretty small as well. Okay. How much also is pretty small, how tall is fine, but if you look at how far, this has the highest probability. Okay. So, the predicting the next word, you now know what is going to be the next word in this case, right. So, when you ask the system to predict the next word for the given corpus, it is going to be giving you how far. Let us plot this to see it a lot more clearer. So, if you plot this using the plot functions which I have listed here, actually you will find the same thing in the code that is available in the GitHub. So, you do not have to really write a code for this. You will see this, you can see that the for has the highest probability. So, we are going to be picking this one as our next word. Okay. So, this is based on the bigram. Okay. In the same fashion, we can also do the similar exercise for trigram. I am going to be showing the application. The application again is available in the GitHub. You can go take a look at that. Again, I have left the corpus space empty. So, you have to go and then fill that space so that you can run the exercise on the corpus. Again, I am repeating, take a smaller corpus to find out how it works. If you want to really try on a bigger one for your production sake, you can go ahead and then do it, but I have to warn you that the longer or a bigger corpus would take a lot of time for building the trigram, 4-gram, 5-gram models and so on. Okay. So, for you to understand the concept, it is enough if you pick up a very small corpus that contains about 300 to 500 sentences. Okay. So, again in this case I am going to be showing the debugging exercise that I had done to demonstrate what the model contains and so on. Okay. So, in this case of the trigram, we have two words that are given, we are going to be predicting the third word, correct. That is how the trigram model works in terms of prediction. Okay. So, earlier we saw in the bigram model how and for occurred. So, we have picked up the first two words, what is going to be the next word. Okay. I can use the same bigram model to go ahead and then do it, but in this case I have picked up the trigram model to demonstrate how this can also be done using this. Again in this case you see that the keys are how far. The construction of the trigram is exactly similar to what we have done earlier. The model construction is very similar, except that you will have 3 words and the count of 3 words and the probability of those 3 words would be computed instead of bigram that we had seen earlier. Okay. Again in the prediction we will be providing W1 and W2 and then we will let the model predict the third word. So, okay. So, if we provide the keys, right, let us say how and for. So, this is going to give us again the list of words that follows how and for. Okay. So, you would see that how far above, how far away, how far behind, how far did, how far does and so on. Okay. There are so many that you will find. Okay. Again you will see the probabilities of each of these words that followed those 2 words. Okay. You will see very small ones and bigger ones again in this case. Okay. Let us see what is our maximum likelihood word. Okay. So, in this case for how far the word is did. So, that means this particular combination occurred several times in this corpus. That is why the word did has a very high probability. So, and you can look at this, this goes like this, and if you sum all of this, you will have 1.0 at the end. Okay. So, I have only picked up the last rather the top 10 words that we have here. So, here this has a very high probability, that means more than half the number of times this has occurred in the given corpus. Okay. So, I guess you have understood what the model is, and then what the model contains, how we are really predicting the next word based on the bigram and trigram models.